somewhat important. So we'll make sure it is recording. All right, so that's good. So what we'll do today is we're going to go through a practice test because next Tuesday is going to be our first exam. Okay, so 1 week from today is exam 1, which is 20% of your grade. Is that okay? All right. So what we'll do today is to go through a practice exam, which is exam 1 the last time I taught this class, which was a year ago. Okay, so this is from a year ago, which is not too far back. And what you can do is to go to the shared folder. When you go to Canvas, you will see shared folder. And what you can do is to click on that one, and it will bring you to a shared Google Drive. Within the shared Google Drive are a few documents. This one is from like 3 years ago. I would not be practicing based on that one. But this one is from last year. And the way you can tell which year or which semester is the year is a little bit awkward. This is from 2018. And the reason why you see 118 instead of just 18 is because that's 0 plus 118. Okay, so that's it's a Y2K issue, but for what we need to know is you just need to look at the second and the third digit. If that is 18, that means 2018. And then the last digit, if it's a 9, it's a fall semester. If it's a 3, it is a spring semester. So we'll just be looking at this one. X1 means exam 1. So do you guys know where to find the practice exam? Just in case you need to do that, okay? So what I'll do is I'm gonna, instead of looking at it like this, I'm going to download it. Well, I think with this class, it's actually okay to look at it this way. So let me zoom in first. There we go. And I go over the test really just kind of step by step, bit by bit. The first thing is you have to make sure that you remember to write down your last name, first name, and student ID in the test. Okay, so you have to clearly indicate and spell out your last name first, and then your given name, your first name, and then a student ID. And please try your best to write down your name because if I cannot read it, it's very difficult for me to know which person deserves those points. Okay, so try your best to write your own name, okay, so that I can read and figure out who you are on my roster. And yes, it is last name first, which sounds confusing, but in many culture, people do use their family name first before their given name. So hopefully nobody finds it to be too confusing. So do we know what to do in terms of filling in the name portion of the exam? Okay, no problem, right? We good? Okay, I'm gonna turn on the air conditioner. It is set to 73, but it's still pretty warm in this classroom. Okay, so moving on. Obviously, the date is not going to be the same, the time is not going to be the same, and the place is not going to be the same. So what we'll do is we'll do it in class next Tuesday, right here in this classroom. Okay, so that's going to be our time, our date, and also our place. The next item is kind of important because it is open material. In other words, it's not just open book or open notes. If there's anything that is on a piece of paper, it's either handwritten or printed prior to the test, you can take it with you and use it to help you in the exam. So that it's not limited to just my notes, it's not limited to just your notes. If you find textbooks that you find useful and you think it might be helpful in your exam, you can bring that too. If you find there are screenshots from the video recording of this class, and you think, hey, this screen is pretty useful, I think I might be fine. I might want to include it. Well, use a program, freeze that YouTube frame, do a screenshot, and then put it into a file and then print it out. Okay, so the only restriction is no electronic stuff during the exam. This is the first year that I'm going to make it very clear. No headphones during the test. So in the past, I can sort of understand that some people feel that, okay, if I put on my headphone and my own music, it helps to calm me down. But from here on, I have to say, no headphones, no cell phone, no connectivity of any kind. Okay. So for those people who think, but I have ADD or ADHD, I cannot take an exam in a noisy environment like in a classroom, then you have to arrange with DSPS and they have to pre-approve that. Then I can give you special accommodation so you can take the test over at the DSPS test center. Okay, but otherwise, in a classroom setting, you cannot have a headphone on when we are taking a test. So is that okay? I mean, this item here, is that okay? Okay. You can bring this test with you, okay? This is a practice exam, so if you think the practice exam can help you in the actual exam, you can bring that with you, okay? So that's fine. Next item, individual assessment. So individual assessment means the score of a particular exam should reflect the competency of the student with the name and ID as identified above, which is where you would put your name, without any prior knowledge of the exam questions. Okay, so that brings up a few other additional points. The next one says answer should be independently and originally derived in the allotted time frame, observing all applicable rules and restrictions. So in this particular case, no electronic stuff, okay? Now, I do allow the use of scientific calculators or graphing calculators. I don't think it's going to be very helpful for what we are doing in this class, but if you think that it's going to be helpful, you can bring along and use a calculator if you wish, okay? I cannot allow people to bring in a phone with a calculator app. That does not count as a calculator. So it has to be a calculator. If a CE 84 plus CE, the color ones, hey, that's fine. I don't think that's going to help you any more than a $1 calculator you can find at the Dollar Tree. But if it helps to boost your confidence, bring it. Do we have any questions up to this point? Nope. Okay. Moving on. No sharing of open book notes, material during the exam. So that means you guys can study together. You can come up with the notes for the exam together. I don't have a problem with that. Okay. The only problem is if somebody forgets. Okay. Let's say I'm one of the students and I forgot to bring my notes. Okay. I cannot borrow that note from any one of you during the exam. So no sharing of material during the exam. Is that okay? Does everybody understand that particular rule? Okay, all right. Next one. Do not discuss the questions with anyone who may not have taken the exam. So if you don't know, make the assumption that the other person has not taken the exam. All right? Okay, moving on. Next item. Use additional sheets of paper if necessary. Now, because we are going to trace algorithms, in this particular test, depending on, how big how much space you need to write. Some people can write, fairly small and they don't need a lot of space, and some people need a lot of space. So the best approach is to bring your own paper so that if you need additional space to write down your answer, you can attach additional sheets of paper. Okay? I will not be providing that to you, so you're going to have to bring your own. On those additional sheets of paper, make sure you write down your name on each one, because just in case I lose track, like you give me a pile of paper and there's no stapler, if I lose track, I will still be able to say, oh, this is so and so's additional paper, it belongs over here. So you need to write down your name and also the question on the additional paper. Is that okay? Does everybody understand? Yes. Any paper that can get through my scanner will be fine. So that means, you can use plain paper, you can use binder paper, you can use graph paper. You might find graph paper to be particularly useful because when we are tracing, it helps to have vertical lines as well as horizontal lines. So if you have access to graph paper from your other classes, that can be helpful. If not, any paper is fine. Okay. Moving on. Write legibly. I cannot give points to answers that I cannot interpret without post-exam explanation. What that means is, if I just kind of squiggle something on the piece of paper, and then after the fact, I told, Professor Tech and say, well, that actually meant x equals to 20. That would not count. Okay, so I have to be able to read your handwriting when I'm grading it. If it requires explanation after the exam, it does not count. So all that really is saying is write legibly. Okay. Next point is make your answers as complete as possible. If there's something I look for to assign partial credit, in other words, I would try to find ways to give you partial credit, but only when you give me a reason to give you partial credit. Okay? So partial credit usually is given when the actual answer is wrong, but I can see your approach is correct, that you actually understand the material to a certain degree, but it's just that, in some of the steps you did something wrong and you did not get the correct answer in the end. Okay, so instead of giving you a 0 at the very end, I want to be able to say, well, it's kind of partially correct, or I can see this person understands the concept. It's just that the application, is not exactly perfect. In any proof of trace, write your answers as completely as possible. Okay. All questions have equal weight, which is helpful to you because when you know that there are, let's say, 8 questions and each question has equal weight, so you know that you should be allocating about 10 minutes per question, right? That makes it very easy for time allocation. But not only that, what you can do is you can glance through all the questions first, pick out which one seems to be the easiest from your perspective, and start with that one. Okay? So I strongly encourage all of you to take advantage of the fact that all the questions have equal weight, because if they are not of equal weight, then you have to kind of compute in your head. It's like, well, this question has more weight, which means it carries more points, but it might take me longer to get through this question. Is it worth the time or the risk to start with this question? But if they all have equal weight, it's super easy. If something seems like the easiest one, start with that one. Okay? So you always start with the easiest question and then move your way to harder and harder questions. This is advantageous because what it does is you get all the points, all the easy points first to begin with. If you run out of time, then you only will be losing points because some of the questions they are harder from your perspective. If you start with the harder questions first and you don't give up, then the harder questions may take up all the time. Then you won't have time to answer the easier questions, even though, so let's say you can only finish like 3 out of the 8 questions because you ran out of time. The 4th question and the 5th question may be very easy from your perspective, but you wouldn't have a chance to get those points because you've spent too much time on the earlier questions. Does that make sense? Okay. So you also want to keep track of time as well, okay? Because you want to keep track of time. If there are 8 questions and we have 80 minutes for the exam, then you want to kind of look at it as, okay, I'm going to allocate myself about 10 minutes per question. At 10-minute mark, you basically just move on to the next one. Because if you don't, and you spend like 20 minutes on one particular question, then you may not have enough time to go through the other questions. So you leave a question, first, and then you can get back to it when you do have time at the end of the exam. That is how I would take an exam. Now, you can choose however way you want to do it. I'm just telling you, but by knowing ahead of time all questions have equal weight, it makes it easier to make these decisions. All right, some questions may cross pages. I try my best not to do it, but if it does happen, you have to be careful, okay? So make sure that you read the entire question and not just use one half of it. In the trace, all the conventions used in class, you have to observe those, which means there should be a column for the line number, a column for comments, and a column for each variable, a row of pre to tell me about the assumptions of the variables, a row of post to indicate the trace is done. And then each time a condition is evaluated, indicate the condition and its value using the comments column. Each time a variable is updated. And by the way, what kind of statement updates a variable? An assignment statement. Very good. Okay, so we know what we are talking about here. All updates of comments and variable need to have a line number specified specific on that row, or specified on that row. The thing is specified. This exam accounts for 20% of your final grade, which means it is the same percentage as all of your homework assignments added together. So the exam is important. Do we have any questions about this part? No questions? Okay. Pre and post conditions from the, remember all the forget, substitution, that sort of stuff. That part is not in the scope of the first exam. Okay. So we'll take a look at some of the questions. Did I miss one thing? Nope. Okay, this is question 1 of 4. I give you the code, you have to trace it. So what do you think here? So make sure you observe the line numbers. Do not assume the line numbers start with line 1. Okay, this one starts with line 185. Is that okay? You have been warned, okay, that these numbers may not start with 1. Okay, they can be randomized in a certain way. So in this case, we have x being initialized to 7. As long as x does not equal to 39, do this block of code. What does the block of code do? If x is less than 39, x gets x plus 17. Otherwise, x gets x minus 1. Okay, so that's what the code is going to do. So what do you think the trace is going to look like? So let's work on the trace here. I'm going to use a different tool this time to work on the trace, just because a browser tool is not as efficient. I cannot position things as well as LibreOffice Calc. Okay. And this allows me to line up things a little bit more easily compared to using a browser-based spreadsheet. All right, so in the space that is provided to you, this is what you need to do. You need to have one column that is labeled comments, one column that is labeled line number, and we only have one variable in this case, which is x. So we have 3 columns in this particular case. The pre is saying, okay, any part of the question tells you what the value of x should be before the first line of the code. I do not see any, so you put a question mark there. We assume it is unknown because we were not told about the initial value of x. And then we start with line 185 this time, because that's how the program or the algorithm is specified. And my computer just froze up. No, it's not entirely frozen. It's just LibreOffice is frozen. My pointer is frozen, but the keyboard is not. That is very odd. Yep, the keyboard is definitely not frozen, but I don't understand why the little touch point thing is frozen. Okay, let me try this. So it's still got a stylus that might still work. Okay. Yep, so that part still works, and it doesn't unstick the, unfortunately, it does not unstick my pointer. So I'm gonna do a little bit of reconfiguration here to re-enable my touchpad. Track point, touchpad, there we go. So I want to enable that. Close. Okay. Nope, it is still not working. All right. Okay, so I'm just have to use my stylus for that purpose. So on one line 185, we're updating x to 7. And then on line 186, what do we do on line 186? comments, okay, because we are evaluating the condition of x does not equal to 39. Now, since I'm only using a keyboard to type it, I cannot really enter not equal to easily, so I'm just going to use less than greater than to represent not equal to. Is that true or not? It is true, because 7 does not equal to 39, so the condition is true. Then where do we go? 187, very good. And what are we doing on that line? We're evaluating a condition, aren't we? So we have to go to the comments line, and then we ask, is x less than 39? The answer is true, okay. And then where do we go? 188, which updates x. X is now x plus 17, because x at this point is 7. 7 plus 17 is 24. So 24 becomes the new value in x. And then where do we go? No. Okay, so at this point we are done with the then branch of a conditional statement. And with any conditional statement, once you're done with one branch, you're done with the entire conditional statement. Where's the end of the conditional statement? Right here. But we don't trace 191 because it doesn't do a single thing. And then where do we go? We are now done with the body of the entire loop. Where do we go next? Back to 186. Very good. Okay, so the next line in the trace is 186. Where we say, okay, is x different from 39? The answer is true, because 24 is definitely not the same as 39. And then we go to 187 again. It asks, is x less than 39? Yep, 24 is still less than 39. And then on line 188, we add 17 to 24, which will give us what? 41. Yes? Okay, 24 plus 17 is, I think it's 41. Yep. This is where a $1 calculator can come in handy. You don't need a $120 TI-84 plus CE to do this, right? Okay, so after 188, we get back to 186. Re-evaluate that x is different from 39. It is still true. Yes?
No, it's true. It's true.
It is true. What?
Yeah.
It does not equal to, right? I mean, do we have any disagreement that 41 does not equal to 39? It is true. Yes? Okay. So that will bring us, that will bring us to 187. X is less than 39 is false. That will send us to which line? 190. And 190 is just going to decrease 1 from x, right? So it goes from 41 to 40. Then where do we go? No. 186 again. Right? 100, line 190 is the only thing we have to do in an else branch. Whenever we are done with one of the two branches of a conditional statement, the conditional statement is done. In this case, when the conditional statement is done, there's nothing else in the loop to do, so we have to go back to the beginning of the loop and re-evaluate the condition to see whether it is time to get out or not. So from 190, we go back to 186, okay? Which is then re-asking the question, is x different from 39? Yep, it is still different from 39, so this is still true. We go to 187, x is less than 39 is false. We go to 190, we decrease x by 1, it is now 39. And where do we go now? This is a little bit tricky. 186, exactly, not post, okay? Because line 190 does not make any decision. All it does is to say x is now 1 less than what it was. So we have to go back to 186 first, where the question is asked. x is different from 39 is now false, then we can get out and then we get to post. Is that okay? All right. Excellent. So what I want you to turn in would be the written form of this. You might say, but this is a lot of writing. I'm pretty sure you guys can do it in less than 10 minutes, right? Yep.
Do we write on the test or on a separate sheet of paper?
You can write on the test, and that's why in the test I leave some room for you guys to write. Okay, my mouse is not working, so I'm gonna have to use this. So this is why I leave some space under a question, so that is the space that you can use to write your answer.
Also, do we have to draw like lines to separate like variables and all of that?
You mean the vertical lines?
Yeah.
Yes.
Yeah.
Because otherwise it would be difficult for me to line up, especially if the trace gets long. So you might want to bring a ruler if you want to. If you do not have a ruler, just kind of estimate, make a line as straight as you can, okay? I'm not going to take points off if a line is not entirely straight. Is that okay? Okay, so we're good with number 1? Okay, so we move on to number 2. Oh, by the way, the number of lines that I provide in the space, under a question does not tell you how long the trace should be. Okay, so do not use that as a clue.
So what would happen if you had more than that?
Then you attach a separate sheet of paper and say you continue on to that separate sheet of paper. Okay? Yep.
Okay, so with a line like that, can I just turn my paper so it's facing this way and have longer?
I would rather not, because that makes it very difficult for me to grade. I have to turn my head to grade it. All right, question number 2. Question number 2 is a little bit different in terms of what it's asking. So I do give you the algorithm, which is based on a nested conditional statement. So we have a conditional statement as the else branch. We have another conditional statement as the then branch. So we have basically 3 conditional statements. The outermost conditional statement starts on line 1, it ends on line 13, but the then branch of that conditional statement is itself a conditional statement, starting on line 2, ending on line 6, and then the then branch of the outermost conditional statement is also by itself a conditional statement, starting on line 8 and ending on line 12. So this question is really asking whether you understand, what nesting means and how we perform the branching, when we have a situation like this. Okay, so the actual question text starts here. It says, is it possible to get to the following lines? And there's a list of lines, over there. And then, if so, specify the value of x to get to that line. If it is not possible, explain why it is not possible. Okay. Okay. So let's see if we can answer that question. Okay. So it is not a trace. All it is to ask, can I get to line 3? Is there a way I can pre-initialize a value into x? Okay, is there a particular value of x so that I can get to line 3? Line 3 is right here. And if so, what value of 3 can lead the program to line 3? So go ahead. So it should be less than 123, right? And it has to equal to 123 at the same time. Is there such a value? No. So you have to say it is not possible. So after line 3, you have to say, in this case, it is not possible, because line 3 executes if and only if x is less than 123 and at the same time equal to 123. That is not possible. Is that okay? All right. What about line 5? Can we get to line 5? Where x has to be less than 123, but it does not equal to 123. I think 122 would do it, right? Okay. So after line 5, you just have to say x equals to 122, or 121, or 120, or 0, or -5, or -5.5. The possibilities are infinite because there's an infinite number of values that are less than 123. Is that good? I would suspect most people would say 122 because that seems to be the most intuitive answer. How about line 9? This one here. How do I get there? Well, let's see how we can get there, right? Because the condition on line 1 has to be false in order for me to execute anything in the else branch of the outermost conditional statement. So that means x has to be greater than or equal to 123 to get to this part, okay? But in addition to getting to this part, it also has to be greater than 80 to end up on line 9. That's pretty easy, don't you think? I think if x is 123, we'll end up on line 9. Does that make sense? Okay? So you can now write down the answer. Right next to line 9, it would be x equals to 123. That is not a unique answer. It can be 124, can be 1,000, can be 5,000, can be 2 million. Okay? But why waste your time writing all those zeros when you can just write 123? Okay? What about line 11, which is right here? How do I get to line 11? The condition of line 1 has to be false because we need to get to the else portion of the outermost conditional statement. But get to line 11, the second condition, which is the condition of line 8, also has to be false. Can you find me a value where it is greater than or equal to 123, but it has to be less than or equal to 80? That is not possible. So you have to write down next to line 11 that it is not possible because no value can be greater than or equal to 123 and also at the same time less than or equal to 80. Is that okay? All right. So that is the kind of analysis that I want you to go through with a question like this. It is not a trace. I'm not asking you to trace the algorithm. I'm simply asking what value of x can get me to a particular line. Are we okay with this? Shall we move on? Are there any questions? No questions? Okay. Yes, go ahead.
Like this will be on the test, most likely?
You mean-
like a practice test? So the
This is a practice test.
so will the questions be similar or
I cannot say for sure because I have not come up with the questions for this semester yet, which is pretty typical of me. Until maybe within 24 hours, I usually do not have any idea of what question I will be asking this semester. Yes?
Can you explain one more time why line 11 can't be true?
Why line 11 cannot be reached? Because, okay, so if you think about line 11, okay, and this is line 11 here. So it belongs to the else branch of this conditional statement, right? So that means x has to be less than or equal to 80. Does that, right? That's one requirement to get to line 11. But in order to end up here, that means we have to get to the else branch of the outermost conditional statement, which means the condition of line 1 has to be false at the same time. Now what?
X is less than 80, but it says x is greater than 80. You keep saying x is less than 80, but it says x greater than 80.
I keep saying x is less than or equal to 80 to get to line 11. Does it make sense? Because the condition of a conditional statement tells you what condition will get you to the then branch. Then how do we get to the else branch? When that condition is false. What does it mean when I say it is not true that x is greater than 80? What is the other way to say that? X is less than or equal to 80. Okay? Now, if you do not like to express that as x is less than or equal to 80, you can definitely just say that it is not the case that x is greater than 80 or not x is greater than 80 because that's equivalent. Okay? All right. So, any other questions about this one? Question number 2. Okay, no questions. Moving on to number 3. So number 3 is another trace. Okay, so you can see that it's mostly traces in our exam here. So let's go ahead and do this. I don't think we have talked about the mod operator yet. Is that true? I think we haven't talked about it. So that means, in a test like this, on next Tuesday's test, I will not use the mod operator. Okay, but since this is from last year or last time I taught this class, I taught it in a slightly different sequence, so the mod operator was already covered. So let me just explain what it does, because eventually you guys will have to learn that too. Mod is kind of like a division, except we keep the remainder instead of the quotient. It's like a division, except instead of keeping the quotient, we are keeping the remainder. Okay, so when we get to that point, I'll illustrate. Okay, so once again, yeah, go ahead.
So let's say like it was like 5/2, the remaining 1 then?
Yes.
Okay.
Yep, there it is. So we got x. The pre says we don't know anything about x because the question does not ask us to assume anything in x. And then on line 18, x is initialized to 0. We do not trace line 19, okay, because line 19 really does not have anything to do. It is only there to mark the beginning of the loop. So we get to line 20. X gets x plus 29, so that makes it 29 at this point. Yep.
Say if we were to put like 19 there, even though it doesn't do anything, will we lose points?
Well, okay, so if I say you do not need to track 19, then just don't track it. The reason why I say that is because in some cases, like in the case of repeat, whether you trace the line that has the repeat keyword on it or not, it's still okay. Okay, but there are cases where it is not okay to trace, like and while, because and while, does it really mean the end of each iteration, or do you mean we are getting out of the loop? So in that case, it is ambiguous. When we are looking at repeat, it is not ambiguous. It is just, it's the very beginning of the loop, except it doesn't have anything to do. So in general, we don't track those lines. Okay? So we get to line 20, x is updated to 29 in this case. We get to line 21. So now we have to kind of use the mod operator. The right-hand side of the expression is x mod 5. So we look up the current value of x, it is 29. 29 divided by 5 is 5 with a remainder of 4. Okay? We do not care about the quotient, which is the 5, but it returns, or it only keeps the remainder, which is 4. Okay, so in this case, x is updated to 4. Don't worry if you do not understand what the mod operator does in this case, because it is out of the scope for our exam on next Tuesday. Okay? All right, so we get to line 22. It is evaluating a condition. X equals to 0 is false. Then we move on to where? Line 20. We go to line 20. This is a repeat until loop. With a repeat until loop, the condition of after the until is the exit condition. In other words, we stay in the loop as long as that condition is false. Okay? X equals to 0 is false, so we have to stay in the loop. So that means we have to get back to line 20. So we add 29 to 4 this time. It becomes 33. On line 21, once again, we look at the division of 33 divided by 5. But once again, we are not interested in the quotient. We're interested in the remainder. What is the remainder of 33 divided by 5? 3. Very good. Line 22, x equal to 0 is false. You probably can see the pattern here already, right? So 3 plus 29 is 32, right? So we put 32 here. 32 divided by 5 has a remainder of 2. So we get to line 22, x equal to 0 is false. you can probably see the pattern, right? You can see how eventually we'll get to 0. On line 20, 2 plus 29 is 31. On line 21, we look at the division of 31 divided by 5, but we don't care about the quotient. We only care about the remainder, which is 1 in this case. On line 22, x equal to 0 is false. And then on line 20, we do the same thing. 1 plus 29 is 30. On line 21, 30 divided by 5 has a remainder of 0. On line 22, x equal to 0 is finally true. Then we get to post. There's nothing after the loop, so that's why we end the trace at that point. So other than the mod operator, which we haven't talked about and will not be in the test next Tuesday, are there any questions about this particular trace? No questions? Okay. So, yes, go ahead.
Would you not go back to line 18 when you're out of the loop?
Which line 18? Oh, this line 18 here? What about it?
You wouldn't go back to it after you finish the loop, after you exit the loop, or you just post it?
We are done. Because line 18 itself is not a part of a loop. So we don't go back to it. So if something is not in the loop, it is just sequential, which means we just keep going forward. Yep. All right, so this is question number 3 out of 4. And let's move on to the next one if there are no questions about this. And no questions. Okay. So the next one is this one. Let's see. Have we talked about the floor operator? Probably not. Okay, well, another. I talked about the topics differently last time I taught this class, and that's why there are operators that we do not recognize in this class. But that's okay. It's pretty easy to explain that one too. But once again, the floor operation is not going to be in the test on next Tuesday. So the precondition is we do not assume anything in x. And then on line 123, x is now initialized to 108. On line 124, what do we do? X does not equal to 0 is true, right? Okay. And then on line 125, I now explain what is the floor. What does it mean to take the floor of something? To take the floor of something, or the floor of something, is the largest integer that is less than or equal to that something. I'll give you an example. The floor of 2.5, okay? Let's think about 2.5. What is the largest integer that is less than or equal to 2.5? Less than or equal to. Okay, I know it sounds confusing because we are looking for the largest, but also at the same time specifying less than or equal to. But the largest integer that is less than or equal to 2.3 is 2. Okay? What about the floor of 1.8? It is 1. Very good. Okay, it's not 2 because 2 is rounding up, but we are not rounding. We are actually just getting rid of the fractional part of it, right? Okay, an even more tricky one. Negative 2.1. What is the floor of negative 2.1? It is the largest integer that is what again? Less than or equal to, in this case, negative 2.1. Negative 2 is not less than negative 2.1. Negative 3 is the answer in that case. Negative 3 is the floor of negative 2.1. If you don't quite get what I'm talking about, once again, do not worry because the floor operation was not covered in this class up to this point, so it will not be in the test next Tuesday. Yes? Say that again?
Which part of the code represents 4?
You cannot?
No, I don't know which part represents 4.
Oh, the floor is applied to the right-hand side of the assignment. Yep. I can magnify it. Sure. Oh, okay. Hold on a second. because remember my mouse is not working, so I have to kind of do this. Should be getting recorded too, so let me just double check. Yep, still getting recorded, so be good. All right, so let's go ahead and trace this one. This is our last one. All right, so once again, we got comments, we got line number, and we got a variable x. Precondition is x is unknown. On line 123, x is initialized to 108. On line 124, we are asking, is that 0? X is different from 0 is true, because 108 definitely is different from 0. On line 125, we do the division. X divided by 2 in this case is 54. What is the floor of 54? Just 54 itself. Very good. So we say 54 here. And then where do we go? 124. Okay, so we go back to line 124. And then we ask the question, does x equal to 0? Or is x different from 0? It is true. We go to line 125. It is now divided by 2 again, which is 27. What is the floor of 27? 27 itself. Okay, pretty easy. Go back to 124. 27 does not equal to 0 is true. We divide it again. And this time it becomes 13.5, right? What is the floor of 13.5? Just 13. We go back there. So it seems like we have a lot of iterations, but it is not, okay? Because we are having it each time. So when we go back to here, it is now what? 6.5, but we're only taking the floor, which is 6, okay? So now it's 3. Now it's the floor of 1.5, which is just 1. And now we go to, you get to 0. Very good, because 1 divided by 2 is 0.5, and then the floor of 0.5 is 0. But we don't put post here, because we have to get back to line 124 first, because that is the line that is making the decision. So x does not equal to 0 is now false. Then we get to post. And that ends the trace. Is that okay? All right. Yep.
Can you use equal sign in the paper because we can write it instead of this big?
You mean to represent not equal to?
I mean in the exam, can you use this equal sign instead of this?
Okay, I cannot see that.
Instead of gate, the number with that gate. Instead of this one, we can use this one in the.
They're not the same. They're opposite.
This one.
Right. You can use that. Yep. Yep. So for those of you who did not quite get what we were talking about, he's asking, can we use this instead of that? And the answer is yes. So as long as you're expressing the comparison and you're looking for not equal to, it is acceptable. So if you want to spell out and say does not equal to, that's fine with me. But why waste your time to write does not equal to when you can choose one of the more easier form to write? Okay. And that's it. I mean, that was the exam for last semester, the first exam from the last semester, or the last time I taught this class. Okay. It is not supposed to be a long test, okay? But it's, at the same time, it is not supposed to be like super duper easy. Question? Yep.
Yeah, so the last 2 questions are not going to be on the test.
No, that is not what I said. What I said was the mod operator and the floor operation would not be on the test.
So what's going to be instead?
Everything else that we have talked about?
Trace.
Yes. So you can bet on, addition and subtraction. It would definitely be possible on the test. Multiplication can be on the test. Division will be on the test. Except, we're not going to take the floor after division. Okay. Do we have any other questions about what is in the test?
So
You first and then you. Go ahead.
do we have anything like we write a definition or something?
Definition?
Yeah, like write a definition of this term or something like that?
No.
So okay, so we don't need to memorize like how to write a definition and all of that.
No. But you do need to understand the definitions. You just don't have to.
Write it down.
Exactly. Yes?
Could you give an example of a condition with a precondition, like a trace with a precondition on it? Like what would it look like?
Okay. So I think the question is, when do we use something other than a question mark in the precondition? Is that right? Okay. Do you guys remember when we talked about how to find the maximum of two variables? Those would be the ones where the precondition is not using a question mark. The question will clearly state, okay, assume variable x has this value, variable y has this value. So when the question has that, then you have to use those specific value for the pre. That's a good question. Yep, go ahead.
Is it possible that there'd be a question on the test where like traces there that we have to get code?
You will not be required to write code in this particular exam. So you'll be tracing algorithms that I have written.
Later on, probably
It depends on the progress of this class. Mastering the meaning of statements is far more important than asking you guys to come up with your own algorithm, because we have to know the statements first. And the way I check whether you guys understand the statements is I give you the code and you trace it. Okay? That's a good question. Any other questions about this particular test? No questions. Yes, go ahead.
We're gonna have to do the analysis for pre and post conditions.
No. So let me show you what is not included. Okay. And not having my pointer working is really okay. Let me see if I can fix that problem by going like this. No, it's still not working. Wait, that's a okay. I'm just using a little bit of a class time, but I want to see if this works. Okay, so let me sign out. That might affect the recording. I might have a recording. Okay, the touchpad is still not working. Touch screen is not working. All right. That is fine. I can still work using the keyboard. It's just a little bit more cumbersome. All right. So this is not included in the test. Okay, so this particular module that talks about pre and post conditions is not in the test. But everything before that is in the test. Is that okay? All right. I have not decided yet. But the idea is I don't want you guys to run out of time just writing the trace. Okay, so that's the idea. Is it's not a competition. It's not. I'm not testing how fast you can write. But other than that, I cannot make any promises. Question.
Yeah, exam plan in November 7th.
No, this is from last semester, and that's why you don't see it on your side. Okay, so just to avoid any confusion, I'm going to get rid of this. Because you see it when I project it, but it really is not the case, so I'm just going to get rid of that. Yep.
Questions from the test?
Huh?
How many questions are in the test?
I think I thought I just answered that question. The answer is I do not know yet. But the idea is I'm not trying to assess how fast you can write. So the idea is I will not give you so many questions that you run out of time, even though you know the answers, but just because it is so long to write, you run out of time. So I will try to make sure that does not happen. Any other questions? So I think the trickiest of the questions that we saw, was the nested constructs, right? You have a conditional statement inside another conditional statement. I can ask a question with a loop inside the conditional statement, a conditional statement inside the conditional statement, a loop inside a loop, and so on. So the idea is not to enumerate and try to understand every single situation, but just to understand what does it mean when we have nesting. Okay, what does it mean when we have a conditional statement inside another conditional statement? Okay, drawing pictures can be helpful. Okay, so when you're trying to study the material, you can draw pictures to help you understand. Okay, what does it mean when we have a conditional statement inside a loop? It really just means that on the outside it looks like a loop, but when you look at the body of the loop, it looks like a conditional statement. That's basically the bottom line. Okay. Any other questions related to the practice test?
How much time do we have?
We have the entire class period, which is 80 minutes. So that's a good question. So if I only give you 4 questions, that means you have what? 20 minutes to each question. Now, I know that I kind of cheated by typing the answer, but if I was to actually write it out, do you think I can write that answer in 20 minutes? I can probably write the answer to the entire test in 20 minutes. If someone gave me the answer and just asked me to copy it on a piece of paper by hand, I can probably do that in 20 minutes. Does it make sense? In other words, you're not going to run out of time because there's too much to write. Any other questions? No other questions? All right. So the exam is next Tuesday, which means if you study and you try to prepare for the test and you find that, okay, wait, hold on a second here, I'm not really quite understanding what this means, or you come up with a particular algorithm by yourself and go like, I really don't know how to trace this, okay? I came up with a code, but I don't know how to trace it, or what it means, or what happens when we try to trace it. You can bring that question on Thursday. That is the reason why I always have 1 week between the practice exam and the actual exam, is to give you guys enough time to study, to prepare, and you have one entire class period to bring any question that you might have so that we can talk about it in class. So I strongly suggest that you guys make use of that opportunity. Yep, go ahead.
I have kind of an unrelated question about homework.
Yes.
Assignment 1, you put a note on it that if it wasn't graded, but you put a note on the assignment that...
That's a good point. Okay. So I found out a few things. So there are certain people where they did not put a link, in this homework submission, even though they shared a document. So those people have to wait a little bit because I have to look for those documents in order to grade. Okay, but I will look and I will grade and I will give full points to the submitted assignment or the documents that are shared with me. There are some other people where I say as comments, it is not shared. Okay, I can see a link. It's not shared. I finally found out why it gave me that complaint. It's because those people just, when they are working on the document, they copy the URL on the browser as they're working on it. In other words, the URL has a /edit at the very end of the entire thing. So when I click, or when Canvas tries to click on that link on my behalf, I'm not the owner of the document, so it won't open. Okay, but when I click on the link, it automatically gets rid of the /edit, then I will be able to actually read the document. So I'm still in the process of backtracking and grading the ones that I could not grade immediately. So if you don't see a score, or if you see a 0 and there's a comment saying that I cannot open the document, it's not shared, just be a little bit patient. I'm still working on it. But I found out why it would not let me open the document inside Canvas. Okay, any other questions? Yes?
So the one when you were talking about the share thing, like the share and acknowledgement,
Yes.
do we just send you another link again? Or
if I write down in comments that it is not shared, there's nothing you need to do. It's actually all good because it is actually shared, but the URL that is on Canvas has a /edit on it, which basically makes the whole thing not work. Yeah. All right. Any other questions before we resume our usual topic? Yes.
Are you going to have assignment 2 graded before the test?
I may or may not be able to do it. I'll try my best to get it done. However, I think the solution is already discussed in class. So, so the most important part is for you to look at the solution that I talk about in class. Because the grade is no more than just a number associated with how close your solution is to the actual solution. Okay. Any other concerns, issues, questions? Nope. Okay. So we can go back and talk about the pre and post condition analysis. Okay. And I think last time we talked about something. Okay, I'm gonna have to open a text editor here.
Oh, I have a question.
Yeah, go ahead.
For my own curiosity.
Yeah, go ahead.
The mod operator.
The mod operator.
What might you use it for other than like the obvious one that comes to mind is determining whether a number is even or odd?
Aha. The mod operator is actually very, very useful in computer science because everything is actually, there's an implicit mod to everything that we do on the computer. So that's the first thing. And then the second thing is the mod operator is useful in base conversion. It's useful in, it really is just a very useful operator. In many type of calculations, we want to know the remainder and not the quotient of a division. Like factoring, okay? So if you want to find out whether a number is a factor of another number, that is what you need to check, is the remainder of a division. And the interesting thing is the remainder of a division is free. If you perform a division on the computer, both the quotient and the remainder are given to you at the same time. So you basically have the remainder basically for free. It's just that sometimes that is what you want and sometimes it's the quotient that you want. All right. Okay, so since I can't really use the mouse, which is very inconvenient on my part, let me just make sure that the recorder is still on. Yep, it is still recording. I'm just going to use handwriting for just about all the stuff, because I can't really easily type in, use a mouse to change the position. All right, so last time we talked about something like this. We talked about line 1 being while x is less than some value k, do. Line 2 is x gets x plus 1. Line 3 is end while. And we are basically saying, how do we deal with the pre and post condition of this thing? That was basically the question, okay? And I drew a picture, okay? And I can redraw the picture. It doesn't take that long to redraw the picture, okay? So to redraw the picture, it kind of looks like this. And by the way, this is not a flowchart, so do not tell other people that you learned how to write flowcharts. Okay, this is not exactly a flowchart. And I personally do not like flowcharts. Okay, so we have a condition here. Okay, so this is the template of a loop. Okay, if you have a loop inside a loop, what is that going to look like? Take this, shrink it, and put it inside the box. That's what a loop in a loop is going to look like. Okay, so in this very specific case, the question we are asking, in order to branch to decide which way to go, this is the true, this is the false branch, is whether x is less than k. X is less than k is true. We go to this block here, which is x gets x plus 1. Okay. So I hope you guys still remember this picture because this is where we left off on last Thursday. Are we good? Okay. So we also talked about the pre and post conditions. So I'm going to label those pre and post conditions again. So we know this is basically the same thing as pre1, which basically means immediately before line 1 executes what we know that has to be true. Okay, that's pre1. We know this one is pretty easy. This is post 3, which basically means immediately after line 3 or immediately after we exit the loop, okay, what has to be true. So we got that one too. So those are the easy ones. We know that this part here is corresponding to pre2. We also know this part here is corresponding to post 2. So I have just identified all the relative positions of the pre and post conditions of each line. Okay, doesn't sound too bad. Okay, and in the lecture of last Thursday, we also talked about we have a very, very systematic method so that if you know what is the precondition of this, we can derive the post. That's based on the inverse function substitution thing. Okay, so it's fairly mechanical. So I can write that down here as well. So we can say the post condition of line 2, if we know what is pre2, is going to look like this. Okay, we use a substitution operation where we take a look at the precondition of line 2 first. We take all the occurrences of x and replace every single occurrence of x with x minus 1, which is the inverse function relative to x. That is how we compute a post operation of a line. That is an assignment statement, and then the right hand side can be seen as a function of the left hand side, and it is reversible. That's what we talked about on last Thursday. Right? So it seems like, hey, we got everything here to solve the problem. No, well, the biggest problem is how do we express pre2? Because I can't really do a substitution until I know what pre2 really is. So here's the problem. Pre2 is a little bit complicated. Pre2 is complicated because there are two ways to get to it. That's not even the biggest problem. The biggest problem is it is a loop. Okay? So what is one way to get to pre2? Well, the first time it is not in the first iteration of the loop. Okay? Pre2 is just related to pre1 and the condition of the conditional statement. Is that okay? So regardless, we know that pre2 has to start with x is less than k. Do we agree on that? Because if x is not less than k, we would have taken the false branch and we wouldn't be ended up here. But now the next question is, what else is going to be true? Well, it kind of depends on whether this is the first iteration or subsequent iterations. If it is the first iteration, then we know that pre1 is still true by the time we are right before we execute line 2. Is that okay? Does that make sense to you? In the very first iteration of this loop, okay, the only thing we know that has to be true is pre1 still has to be true because between here and here, we do not have a chance to change anything. Okay? But what if we are looking at the second or later iterations? In other words, what if this is not the first time we got here? Okay, we got here because we looped back already. So in that case, we also know that post 3 or post 2 has to be true. So we have a post 2 here. I think this is exactly where we left off last Thursday. Do you see a problem? Do you see a problem where post 2 depends on knowing what is pre2 and pre2 depends on knowing post 2? We kind of have a circular reference here. So the question is, well, how are we going to resolve this circular reference? So the idea that we need to use is called a loop invariant. So I'll spell out the term first. So we want to look for what we call a loop invariant. So a loop invariant is a condition, okay? Just like x is less than k is a condition. It is a condition, but it's a condition that remains true in the pre-condition as well as the post-condition of the entire loop. Okay? So this is the magical part, but how do we find the loop invariant? Okay, that is the next question. I cannot tell you the procedure to do it, but in this case, I can just tell you what it is, and then we can plug it in and see if it works. Okay, so I'm going to say the loop invariant is x is less than or equal to k. Is that okay? So I'm going to say that the loop invariant is x is less than or equal to k. I'm claiming that this remains true as long as we are in the loop. Okay? So now we have to test it. Okay? We have to basically plug it in and see if it works. Is that okay? So the way we plug it in is we are basically saying, let's just assume that post 2 is our loop invariant. Okay? And we'll see whether we can, we'll see whether that works or not. So everywhere we see, post 2, we replace it with x is less than or equal to k. Okay, so we use, let's use a blue here. And we just say, okay, replace this with x is less than or equal to k. And post 2 here, okay, we want this to eventually boil down to x is less than or equal to k. But we have to check to see if that works. Okay? Are we doing okay so far with this? Okay.
That's kind of a question.
Yes, go ahead.
So just from my own thinking, so if what's inside the box was x gets x plus 2, then your statement of what the invariant is couldn't be x is less than or equal to k still, right? Change that.
No, it would still be x is less than or equal to k because that is still the loop invariant as we are. Oh, I see what you mean. Okay. Yep. Because you're skipping by more than one.
So then you can't know.
Right.
So,
So it would have a different loop invariant, or you would express it in a different way. So in that case, it would be x is less than or equal to k plus 1. Because you can skip k and jump to the k plus 1. Yep. Very good. Okay. So the next question now is, what should we use as pre-1? Okay, because right now pre-1 is just saying, okay, whatever condition that has to be true prior to the execution of line 1. So if I want to make this as general as possible, I will make pre-1 equal to true. Okay, because when you say pre-1 is true, all you're really saying is, oh, we can at least get to this line, but we don't know anything about k nor x. Okay, so we can turn it into a, well, yes, so we can turn it into a true. Okay. Okay. All right. So right away we can see, well, okay, I wouldn't say right away, but I think some of you can see that, hey, this looks kind of familiar. We have a OR where one side is true. So when one side of a OR is true, what happens to the OR for sure? The whole thing has to be true. Okay. So that means this entire thing is just true. Okay? Then we recognize another thing. Because we basically say, what is this saying? Something and true. What happens to something and true? What is that equivalent to? Not false. Not true. Whatever we start off with. Okay? Because false and true is false. True and true is true. So if you say blah, blah, blah and true, there's no need to say and true. Okay, that is just redundant. It doesn't hurt anything, but it's not needed either. So we take this out, okay, because that is not needed. So that means if I assume that x is less than or equal to k is the loop invariant, the precondition of line 2 just boils down to x is less than k. Are we good so far? More or less, kind of. Okay. So is that going to work out to the post-condition derivation? In other words, if I carry this out, because now I know what is pre2, which is just x is less than k, and I look for all the occurrences of x and replace every single one of those with x minus 1, what do we end up with? Okay, well, that's not too hard. We replace the only x with x minus 1. That whole thing is less than k. And hey, that doesn't look like x is less than or equal to k. And you would be right, okay? But what if I say x is an integer? Think about it. If I say x is an integer, let's rewrite this in a certain way first. Okay, so I'm going to say x is less than k plus 1. Can we buy this? That these two statements are really saying the same thing. X minus 1 is less than k is equivalent to x is less than k plus 1 because I just add 1 on both sides. Is that okay? All right. But what if x is an integer? What if we know ahead of time that x and k are both integers? Can we now say that x is less than or equal to k? Okay, put a question mark here because that's what we're considering. What do you think? K is an integer. So when x is less than, both x and k are integers. When x is less than k plus 1, and you just add 1, is that the same thing as saying x is less than or equal to k? So the way you think about this would be the boundary case. Just think of an example, okay? So in order for this to be borderline true, which means this is the last value of x to be true, x is going to be the same value as k, right? Well, it also meets that requirement. Okay, so that's one way to think about it. So we can now remove the question mark because we now know that we can establish that. Okay? So it does work out, okay? Because we get our loop invariant back as post 2. Is that okay? Well, in that case, can we work out post 3? That's the question. The next question is, can we work out post 3? So we look at post 3, and let me just kind of scroll back to the picture first. So the question is, if I end up here, what do I know has to be true for sure? Well, one thing I know for sure is x is less than k has to be false. Is that right? Because if x is less than k is true, I would still be in the loop. The only time I can get to post 3 is x is less than k is false. Is that okay? All right? Okay, so we'll say that is the case. Okay, so we know one thing that has to be true is it is not the case. Okay, this is negation or not. X is less than k is true, or x is less than k is false. What else do we know? Well, once again, there are two ways to get out of the loop. It is entirely possible that x start off with a value that is greater than or equal to k, so we don't even bother to get through at least once in the loop. That's possible because I did not tell you anything about x or k as in pre-1. So it is entirely possible that x is already greater than or equal to k to begin with. All right? So technically speaking, we have to say pre-1 because whatever is true in pre-1 is still true at this point. But it is also possible that we have gone through at least one iteration. So if you think about, this is a loop. We have gone through at least one iteration, and we get to this point, and we are branching off this way. So that means post 2 can also be true. So we're going to add that to post 2. I know we are running out of time. Like so. Yes. Okay, so very quickly, okay, we can do the same kind of simplification. We can cross this out because this is true or something. So the whole thing on this side becomes true. Something and true is just whatever something is on the other side. So the only thing you know for sure after at post 3 is x is greater than or equal to k. Okay, so I'm going to stop it at this point, just because we are running out of time. But if we can guarantee that x is initially less than k to begin with as pre-1, then the answer will be different. Okay, so next time when we talk about this, which is on Thursday, we'll make that assumption about pre-1.